So, hello friends, once again, you are welcome to my channel. In my presentation session on the topic Human Factors from the paper Effective Technical Communication, I am Dr.Shiuli, Assistant Professor in English from the Department of Humanities, Greater Kolkata College of Engineering and Management. So, human factors engineering, also called ergonomics or human engineering science, dealing with the application of information on physical and psychological characteristics to the design of devices and systems for human use. The term human factors engineering is used to designate equally a body of knowledge, a process, and a profession. As a body of knowledge, human factors engineering is a collection of data and principles about human characteristics, capabilities, and limitations in relation to machines, jobs, and environments. As a process, it refers to the design of machines, machine systems, work methods, and environments to take into account the safety, comfort, and productiveness of human users and operators. As a profession, human factors engineering includes a range of scientists and engineers from several disciplines that are concerned with individuals and small groups at work. We move on to the next slide, which talks about the aim. The aim of this presentation is to give an introduction into what human factors are and what can affect them. The terms human factors engineering and human engineering are used interchangeably on the North American continent. In Europe, Japan, and most of the rest of the world, the prevalent term is ergonomics, a word formed from the Greek words ergon meaning work and nomos meaning law. Despite minor differences in emphasis, the terms human factors engineering and ergonomics may be considered synonymous. The terms were used in the 1920s and 30s to refer to problems of human relations in industry, an older connotation that has gradually dropped out of use. Some small specialized groups prefer such labels as bioastronautics, biodynamics, bioengineering, and manned systems technology. These represent special emphasis whose differences are much smaller than the similarities in their aims and goals. Next, we move on to the origin of human factors. A program initially designed by the Federal Aviation Administration (FAA). The focus is on the employees who build and maintain all aircraft engines and aircraft. And the tools and techniques have been modified for the needs of all businesses. Two general premises characterize the approach of the human factors engineer in practical design work. The first is that the engineer must solve the problems of integrating humans into machine systems by rigorous scientific methods and not rely on logic, intuition, or common sense. In the past, the typical engineer tended either to ignore the complex and unpredictable nature of human behavior or to deal with it summarily with educated guesses. Human factors engineers have tried to show that with appropriate techniques it is possible to identify human machine mismatches and that it is usually possible to find workable solutions to these mismatches through the use of methods developed in the behavioral sciences. We move on to the next slide, that is the need for human factors we'll be discussing. So the second important premise of the human factors approach is that typically design decisions cannot be made without a great deal of trial and error. There are only a few thousand human factors engineers out of the thousands of engineers in the world who are designing novel machines, machine systems, and environments much faster than behavioral scientists can accumulate data on how humans will respond to them. More problems, therefore, are created than there are ready answers for them, and the human factor specialist is almost invariably forced to resort to trying things out with various degrees of rigor to find solutions. Thus, while human factors engineering aims at substituting scientific method for guesswork, its specific techniques are usually empirical rather than theoretical. So, the need for human factors is that human factors, when understood, can greatly benefit the person in a system. These benefits are effectiveness of the system, the safety, efficiency, and well-being of crew members. The next is the objective. Human factors engineers regard humans as an element in systems, and a human machine model is the usual way of representing that relationship. The simplest model of a human machine unit consists of an individual operator working with a single machine. In any machine system, the human operator first has to sense what is referred to as a machine display, a signal that tells the individual something about the condition or the functioning of the machine. A display may be the position of a pointer on a dial, a light flashing on a control panel, the readout of a digital computer, the sound of a warning buzzer, or a spoken command issuing from a loudspeaker. Hence, sensed the display, the operator interprets it, perhaps performs some computation, and reaches a decision. In doing so, the worker may use a number of human abilities, including the ability to remember and to compare current perceptions with past experiences, to coordinate those perceptions with strategies formed in the past, and to extrapolate from perceptions and past experiences to solve novel problems. Psychologists commonly refer to these activities as higher mental functions. Human factors engineers generally refer to them as information processing. So, the objective is to characterize the impact of environmental, that is, external and internal, and individual factors on human performance, to understand the chain of events that cause defects or errors in daily business operations. These events can lead to the endangerment of the employee or the customer of the product or service, create awareness and to examine the human role in the workplace. Next, we move on to what are human factors. Human factors have four key elements in understanding human factors, like liveware, that is the person, you and I; hardware, that is physical, example given your chair; software, that is non-physical, example given SOP; environment, that is situation in which the LHS system interact. So what are human factors here? A human machine system does not exist in isolation. It exists in an environment of some sort. Since the nature of this environment influences the operator's efficiency and performance, the human factors engineer must be concerned with such environmental factors such as temperature, humidity, noise, illumination, acceleration, vibration, and noxious gases and contaminants. A human machine example, like driving an automobile, is a familiar example of a simple human machine system. In driving, the operator receives inputs from outside the vehicle, that is sounds and visual cues from traffic, obstructions and signals, and from displays inside the vehicle such as the speedometer, fuel indicator and temperature gauge. The driver continually evaluates this information, decides on courses of action and translates those decisions into actions upon the vehicle's controls, principally the accelerator, steering wheel and brake. Finally, the driver is influenced by such environmental factors as noise, fumes and temperature. So, human factors, we have organization, individual, job and system design. Please have a close look at the diagram. Here under organization we have safety, climate, change management, communications and action, structure or hierarchy. Individual is competence, training, behavior and attitude, risk perception, job satisfaction. For the job, here we have schedule, workload, operations and procedures and supervision. And for system design, we have interface design, alarm handling, physical workplace, manual handling and working environment. So we move on to the next slide, that is human factors definition. So human factors entails a multidisciplinary effort to generate information about human capabilities and limitations. This information is applied to equipment, systems, facilities, procedures and job training for continual and effective human performance. The single human machine model provides a convenient way for organizing some of the major concerns of human engineering: the selection and design of machine displays and controls, the layout and design of workplaces, design for maintainability and the work environment. Next comes the human factors in incidents. So as we know, like human factors do come in large systems, like no matter how important it may be to match an individual operator to a machine, some of the most challenging, complex human problems arise in the design of large human machine systems and in the integration of human operators into these systems. Examples of such large systems are a modern jet airliner, an automated post office, an industrial plant, a nuclear submarine, and a space vehicle launch and recovery system. In the design of such systems, human factors generally human factors engineers study. In addition to all considerations previously mentioned, three factors like personnel, training, and operating procedures. Systems are generally designed for particular kind of operators. A space vehicle, for example, is designated for a highly select handful of astronauts. Automobiles, on the other hand, are designed to accommodate a wide spectrum of people. In large systems, actually, the specification of personal requirements is an integral part of the system's design. So, what are human factors? It is the liveware, that is the person, you and I. As we said, in the center of the model is the person, L, the critical and most flexible component in the model. We are subject to variation in performance. Edges of the blocks HSE are ragged. Blocks in model must be carefully matched if breakdown is to be avoided. So next we come to the other slide, that is what characterizes an effective employee. So personnel are generally trained, that is, they are given appropriate information and skills required to operate and maintain the system. System design includes the development of training techniques and programs and often extends to the design of training devices and training aids. Instructions, operating procedures, and rules set forth the duties of each operator in a system and specify how the system is to function. Tailoring operating rules to the requirements of the system and the people in it contributes greatly to safe, orderly, and efficient operations. So here we have the interaction of human factors. We have people, workplaces, and management all merging into one another, explained with the help of a kind of a Venn diagram. So people are the individual factors with knowledge, expectations, attention, goals, health, fatigue, age, culture, body size, strength, stress, and so on. Next we have the workplaces, that is the workplace design, which has facility layout, workstation configuration, accessibility, and so on. Equipment design, which has displays, controls, interface, feedback, warning systems, ease of use. And work environment, that has noise, vibration, lighting, temperature, chemical exposure, and so on. Next we have the management, that is systems organizational management. Here the organization of work, policies, management, decisions, etc. Job design like work schedule, workload, task design, job requirements, and so on. Next is information transfer, that is communication, written and oral, instructions, labels, signs, and so on. We move on to the next slide, which talks about the attributes of human factors. So human factors have some dependable attributes like willing to put in effort and hours, high integrity, modest, distrust of words, and prefer to be allowed to make his or her own decisions. On the other side, it is doesn't like to ask. Some are there who doesn't like to ask for help, tends to be self-sufficient, like to think things out on his or her own, and doesn't share thoughts too frequently. We go to the next slide. So here we see human factors, the dirty dozen. There are some daily pressures like lack of communication, complacency, lack of knowledge, distractions, lack of teamwork, fatigues, lack of resources, pressure, lack of assertiveness, stress, lack of awareness, norms. So we move on to the other side. Next slide, that is human factors, communication. So communication in human factors are of specified into these 4 types, like written communication, verbal communication, tone of voice, and body language. So, does this sound familiar? What you heard and what I said are totally 2 different things. And what you think I said is definitely not what I meant. So, ergonomics or human factors is a scientific discipline concerned with the understanding of interactions among humans and other elements of a system, and the profession that applies theory, principles, data, and other methods to design in order to optimize human well-being and overall system performance. So, to improve communication, we must first learn to listen, ask questions, paraphrase, make eye contact, use positive body language, approved process or worksheets, discuss open items on paperwork, and finally, never assume anything. So next we'll be discussing human controlling the human error. The control of human error requires 2 different approaches. First is minimize occurrence of errors, high levels of staff competence, design controls to match human characteristics, provide proper checklists, procedures, SOPs, etc., and reduce stressful conditions. reduce consequences of remaining errors by cross-monitoring crews and close crew cooperation. So, to finally, before summarizing, what we find is that human factors actually, first of all, we know what are human factors, which interfaces play a part in human factors, the errors that can occur with the interaction of the interfaces, and name the 4 key elements of human factors. So, human factors play an active role in developing a mature practice in usability or user experience design, a seamless suite of consulting, training, certification, and tools. So, it is the application of psychological and physiological principles in the engineering and design of products and processes. Thank you.